we will start with our presentations. So we have here more presenters who will make their presentations. There is one small change in the program. The presentation about blockchain will be done after presentation of defining of the field borders, and then will be two presentations which will be focused mainly on management zones. So the first two presentations will be done by Hermann Schneeweiss. He is working for Wireless Info, and he is our specialist for remote sensing or Earth observation, how it is called, and he will start make presentation generically about usage of Earth observation in agriculture, and then he will continue with the method of classification and also with detection of field borders. This presentation is the part of AgriHub INSPIRE Hackathon. This is second webinar which we are organizing. On the end, I will inform you about the next webinars, and if you are interested to cooperate, you can join our teams on the INSPIRE Hackathon, and you can cooperate or test it, this new method. So I would like to ask Hermann. Hermann, please, you can start with your first presentation.
Thank you, Karel, and good morning to everybody. I have to share my screen, not to forget it. And I hope you see it and you hear me well. And I want to give you or give everybody a brief introduction to the topic, and to see the motivation of why should farmers use satellite remote sensing, and why is it good, and what are the obstacles, and to just to know what are we talking about. It will not be the history lecture, but I will start with the view of remote sensing roots. Then we will talk a bit about the state-of-the-art satellite platforms. Then one slide for physicists. And at the end of the presentation, we will take an honest look at the practical use of the satellite images. And then we will see some motivation for the farmers. So it will be very brief, and I hope we will get soon to the more practical presentations. In a certain sense, we could date the beginnings of remote sensing back to world wars, when aerial imaging map surfaces for military purposes, but soon the images found application in agriculture and forestry. However, a major turning point in the development of these techniques came in 1950s with the development of space programs. And the most famous and used satellite platforms are Landsat satellites from NASA and Sentinel satellite family from ESA. Both of the products are freely available online. There are also some commercial satellites, but they are not free and they are not so widely used. Landsat is the oldest satellite system designed to provide regular information about the Earth's surface. The first satellite, Landsat 1, was launched in 1972, and Landsat 9 is the newest satellite of this family, and it is in service from January this year. ESA's space program is much younger than NASA's one, as it started in 2014 with satellite Sentinel-1, but still ranks the most important source of remote sensing data. Sentinel-2 satellites don't have the history of the Landsat satellite series, but provide more frequent data with better resolution. Now I'll say a few words about the technical parameters of the satellites. All of the satellites we are talking about are multispectral. It means they capture several wavelengths of the image, not only RGB. And to be specific, I'll choose the most used satellite for land monitoring and show you its parameters. This picture shows bands of Sentinel-2. And yes, Sentinel-2 camera, so-called multispectral instrument, scans the Earth in 12 spectral bands at different space resolutions. Some bands have 10 meter resolution, some 20, and some 60. But good news is that the most important bands for land monitoring or crop monitoring are provided with a 10 meter resolution. And the data is provided in tiles which are 100 times 100 kilometers. The revisit time is globally 10 days, but the Sentinel-2 satellite works in pairs. So there is 2A and 2B satellite on the opposite side of the planet. And it decreases the revisit time of Sentinel-2 satellites to 5 days globally. And for European countries, it is even 2 to 3 days. So quite often. And this slide shows how crop monitoring from satellite works. We measure the reflectance of the vegetation on the fields. It explains why vegetation is green, because there is chlorophyll in vegetation absorbs red and blue wavelengths, or light, and it reflects green light. So vegetation is green, and very important is so-called red edge in this part, when the reflectance is changing very rapidly. And when the crop is stressed, there is less chlorophyll and the reflectance changes. So the vegetation indices, which are used for crop health monitoring, offer you some ratio between reflectances at different wavelengths. For example, NDVI, the most important used one, uses ratio between band in near infrared area, somewhere here, and band in red area, somewhere here. And for health crops, the ratio is quite high, and for more dry or not so dense crop, the ratio decreases. And good news is that we see there are 3 bands in the red edge area in Sentinel-2 satellite. So it's good. And so far so good, everything sounds nice. every 3 days, there is a free satellite image with sufficient resolution, which is able to monitor crop condition. But to be honest, I also have to mention the limits of remote sensing. The main physical limit is cloud cover, because the multispectral instrument doesn't penetrate the clouds, and the camera only sees cloud cover. This is, for example, these images are from April 2021, and we see there are 2, maybe in some areas 3 images available in April, and yeah, our farmers are happy when there is some precipitation and clouds, because they often struggle with a drought. But the GIS specialists are not very happy because there are no usable images. And we see it's quite important problem, because it can be 2/3 of images completely covered with clouds or unusable, and then there is many images covered partly with clouds. But to conclude this part positively, there is a hope for remote sensing, and its name is radar satellites. Radar differs from optical camera because it penetrates the clouds without any signal distortion. And the first member of Sentinel family is a radar satellite. Sentinel-1 has also a 10-meter resolution and provides the data every 2 days, so it's good. However, even Sentinel-1 has a limit, and the limit is the data interpretation. A radar signal is influenced by many more variables, so it is not straightforward to make conclusions from the data. And now just 2 slides to motivation, because it's very clear. Even the ecology is these days quantified by money. So everything is market driven. Precision farming enables farmers to use much less pesticides and fertilizers. So it is a very important source of savings. And there are lots of studies how variable rate technology saves the money, but I chose just this to show you the approximate savings for farmer. And that's all from this presentation. And maybe I will continue with the second presentation.
Yes, you can start immediately. Go with second presentation.
Yeah, I want to start from the beginning. Yeah, and then we will now get to more practical things. What can Earth observation specialists do with that? How to make some variable rate application. And this presentation is first because field borders are the main prerequisite or
the presentation of Director Kanina. It was really, really good. We're so excited. But
sorry, can you mute your mic? Okay, thank you. yeah, the main things which are which is needed for making some progress, because the aim is some savings or some ecological progress. The most important tool for that is variable rate technology, variable rate application of the fertilizers, which saves the fertilizers quite significantly. But for the variable rate application, we need homogeneous zones, which tells us or tells the machinery which zones have to have the amount of the fertilizers. And for homogeneous zones, we need homogeneous fields, and it means we have correct field borders. I will show it more better with the pictures. So this is the final product for machinery, which tells the machinery in which area it should give a certain amount of fertilizer. It is usually in liters per hectare. And yeah, this is the final product we need. And the way for it to get it is through Earth observation or through monitoring from satellites. We use vegetation indices. We often use some longer history to know what is the potential of the yield potential of the fields. But for that we need correct field borders, and on this picture we see there are not good borders, because for example in this part it is clear that the differences of yield potential is not because some heterogeneity in the field. Like in this field, this field looks good, that in this part there are usually higher yields, and in this part the yields is lower. However, this field is not correct, because it is clear that there were different crops. We cannot compare different crops because they have different vegetation peaks or values of the indices. So something like this. This is also yield potential, but the fields are divided, and we know what is the potential of each pixel or each area in the field. And based on this map, we are then able to do this prescription map or application map for the machinery. And now how to do the correct borders. There are in some countries there are some national database of borders, but even if there are some, they are not correct in all cases. So we also make use from satellites. These are just 4 example of images from a season of some vegetation index, and we see that the fields
Okay, thank you, Herman, for your presentation, introduction to the problem, and also some demonstration what we need to do. I don't know if is now some question to Herman, or of course there will be also space for the question on the end. So if you have some question, you can or switch yourself and ask or write the question to the chat. So it seems that till now not. So in such case, I would like ask Jiří Kvapil, and he will a little make short presentation about very popular technology, blockchain, and about our test integrated blockchain into all processing chain of delivering the data from processing to the customer, because this is probably the space where we can see some importance of blockchain, but I think that Jiří will tell you more. Jiří, floor is yours.
Hello, good morning. Thank you, Karel. So, yes, blockchain.
Please, can you change the mode of presentation, because now we see not presentation, but we see your PowerPoint. If you can start as presentation.
Okay, so give me a second. So I need to stop sharing and start sharing again, because I changed it to presentation mode during sharing. So I'll just start over. So how does it look now?
Good.
Okay, thank you. So blockchain, it's some kind of buzzword and everybody speaks about, and it's like yet everybody's talking about and nobody has seen it, or not so many have seen it. So first of all, I will try to explain what is blockchain, some very basic principles, and then what we have done, some demonstration test case, how satellite data can be published or can be sold using blockchain technology. So what is a blockchain? Blockchain is based on transactions. So whatever purchase or sell you make, it's a transaction. So here I have an example. I am a farmer with this yellow raincoat. I have a greenhouse with tomatoes, and I'm producing these tomatoes, and I want to sell them. I want to put them on the market. So I'm just reselling these tomatoes to this big storage, to the wholesale company, which is selling it then to the smaller shops and the customers. But now I'm just for this showcase, I'm selling 100 kilograms of tomatoes from producer to the wholesale operator. So this is one transaction. This transaction is recorded in my blockchain. So here in the text, you can see on a real example of use your blockchain. So you can see that I'm a farmer, and I'm selling this to a destination, which is a distributor, and I'm selling asset, and the type of asset is product, and my product is tomatoes. It's just test case, and I'm selling 100 amount of tomatoes, and my units are kilograms, so I'm selling 100 kilograms. The blockchain is based on transactions, and these transactions have the most important part in their hash. You can see the long string highlighted with green. So this is a unique hash of this transaction. And under this transaction or under this hash, this transaction is stored in my blockchain. And this hash tells or assures that this transaction cannot be, let's say, changed, or this is a checksum of a transaction when all this information, like the source of this transaction, the destination, asset, and also on. And very important is also the timestamp. So it tells you that this transaction was sent this exact time with these parameters. Once it's done, it cannot be changed because it's the principle of blockchain. Should you request to change it, then whole blockchain falls apart. I will show you right now. So our example is this first transaction, this T1. I have just used this first 6 or 7 letters of this very long hash, which is on the bottom of the screen. So this is one transaction. Then I have other transaction T2, T3, 5, and 4. For this blockchain, in this example, I have 7 transactions in this block. This yellow rectangle, this yellow sheet is a block, like the sum of these 7 transactions. And also this block has hash as well. Okay, so well, can I ask you not to have your mic on when you are not talking to public? Thank you. So, and having this block of these 7 transactions also hashed, I can be sure that this block is already closed and that never ever anybody can change any of these 7 transactions within this block, because once I would change any of these 7 transactions, all the hash of the whole block would change and it would fall apart again. It would be broken. So once the transaction is there, it cannot be changed. And the principle of this, I would say, clustering of transaction is that you don't need to use every hash or every checksum of every transaction. You just, when you fill this block, you just make a checksum of this block, then it's faster, because you don't need to go through every transaction, just check the blocks. But of course, in principle, there's not just 7 transactions, there are maybe 10,000 or hundreds of thousands of transactions within a block. So when I fill a block, I start a new one. So with transaction number 8, I have start of a new block, and then when I fill another block, I have to calculate the checksum of hash of the other block, and by this I'm closing this block, and I can start another one. So you can see the blocks that are chaining. So therefore the name blockchain, or also in English it could be ledger, like a financial book where you are placing records. In our principle, or in our case, it's every record is a transaction. And once you fill in the whole page, in our case, it's block. You just in the ledger, in the paper ledger, or in the paper book, you just turn it to the other page, and on the top of the page, you just copy the balance which was on the previous sheet. So it's something similar, but it's much more sophisticated, because you cannot change the transaction here, because once it's there and when it's secured by the hash, it cannot be changed, because all these blocks, all these previous blocks are part of the following blocks. So for example, if I'm having this, sorry, there should be B3, this third block, if I'm having this checksum for B3, it already contains checksums or hashes from transactions 15 to 21 on this actual block, but also it also contains the hashes for block 2 and block 1. So in this principle, this block contains 7 transaction block, 7 hashes of the transaction in the block 3, plus 2 transactions, plus 2 hashes of sums on a book on a block 2 and block 1. I'm just taking this much longer because this is very crucial for understanding of blockchain. So I'm trying to understand it really some far away, because in this way you understand blockchain independent of any operation, whether it's cryptocurrency or something we are trying to do now. So, and then I have block 4, again the same, all the transactions under block 4, then the checksum for the whole block, and then I have another blocks which all have these transactions. So this is the very basic principle of blockchain. So blockchain, it's one could say, okay, so it's just a database. Of course it's a database, but it's mostly distributed database with fraud protection, as we have already seen, that no one can alter or change the transaction which has been done in a blockchain, because from the technological principle, it's not possible to. Should you do it, then the whole blockchain falls apart, because then all the hashes of the previous operations wouldn't fit. So then it would be inconsistent, and you would destroy the blockchain. Of course, the blockchain software doesn't allow for this, so it doesn't allow you to make any changes, because it wouldn't be possible to. It would be against the technology. So here in the case, I have different nodes. You maybe know that there's not a single point where all these transactions of the blockchain are stored. For example, all these cryptocurrencies, it's distributed among many peers, many users. So, and all these users are called nodes. So here I have four nodes, node 1, 2, node 3, and node 4. And all these nodes are servicing several transactions. And it doesn't matter which transaction goes to which node, because after all, it's everything is synchronized in this let's say blockchain world or the distributed cloud or whatever. So this is the ideal case. Of course, you don't need to have it distributed. For our case, we just did it on a one server, but from the principle, it's the same. It's this is a situation. I mean, the sharing of peers, that the whole blockchain is distributed among many peers. It's that. For example, if you don't know the others and you don't trust the others who are sending something, for example, like cryptocurrency, so you get the public trust by dividing the blockchain into many nodes, which are continuously synchronized. So, and now to our test case, we have tried to use blockchain for distribution of digital data. You know, there are already companies who are selling music and movies and whatever like this, giving a unique hash to their files, and then they assign the unique hash of the file to your account that they can prove, or you can prove you have purchased it. And we are doing something similar. So we have developed map application on top of blockchain. There are several services which are running or which are making the connection between blockchain and this application. So within this era, within this orange rectangle, there's a era we have put some NDVI image as a test case, and on a map you can select a rectangle, draw a rectangle within this area. So here you can see that I have a balance of 336 point something currency, gold coins. We don't use any currencies, just a test, so we can call it credit. So I have 536 credits, and for these credits I want to buy some data. So first I select area in the map, I draw a rectangle. You see this white rectangle in the middle of the map. So it's a preview of the price on the left side. In the circle, you can see the price is 62 credits. So if I'm okay with this, I click buy, I get it. And you can see that my balance was decreased by this amount because I have just made a purchase. And then on the left side, in the left column, you can see that in my purchase history, I have another record edit. And then when I click it, I have the data available because there was yet another service which made a smaller raster clipped from the overall image once I have paid it and requested it. So in the background, it created a smaller crop of this raster image of NDVI. So, and what happens if I request a large area? So I put it back a little. So have a look at this white, or this very pale, I would say, pale rectangle. And the other one is, let's say, maybe 3 times higher or bigger, sorry, larger. So, and this one would cost me 179 credits, I would say. So you can see the price is calculated based on the area I'm requesting. So larger area, higher price. Of course, there can be implemented some discount models or whatever, but this is just a business case. It's not a technical issue. So here we are increasing the price of the selection based on the area. So I think it was all from my side, and if there are any questions,
Yuri, there are 2 questions in chat. Yes, first is from Anna V. What is the condition to finish a block and begin with another one?
Well, it depends. It's internal on the software. It's serviced by the blockchain software. You as a user, you don't care about this. You know, it's done automatic. It's something like when you are storing files on your computer, you also don't save in which sector on the disk it's placed. It's done in the behind by the operating system. Also, something here is done by the blockchain. So the blockchain decides. is internal structure of the blockchain.
Okay, and second thing is probably similarities from Karolina Lehocka. Does a block always contain 7 transactions?
No, it's just an example. You know, it was an example that I could fit it on the screen. So, and it was still visible. So, you know, I just show 7, it could be 5 or 10,000, but I would hardly show you 10,000 records on my screen. So I just wanted that you can see it properly. So it was just an illustration.
Okay, is there any other question to Yuri? Because Yuri will probably left, he will be not able to stay till the end. So if there is some other question to blockchain, please do this now. If not, thank you, Yuri. And the next will be done by Dimitri or Jan.
I can do this presentation. Yes, just a second. I will share the screen.
Okay, so next will be focused on generation of management, automatic generation of management zones from different indexes.
Could you please let me know if you can see the screen?
Yes, but the same as I told to you.
Okay, I see.
It is in PowerPoint, not in presentation mode.
Yeah, just a second. I will also turn on the video. Okay, so my name is Dimitri Kozhuk, and I work for Plan for All Association. And now, basically, I will continue what Herman was saying in his presentation, and I show some practical example how this basically field management services can be created for farmers, and I will demonstrate some live example of applications that creates such management zones for farmers. So let's start. So basically, for what we need management zones, because these zones on the field, they have some similar potential for vegetation health, for basically yield. And so if we divide the field, partition it in these zones, we can then manage it easier. We can basically add more minerals to the parts that are more poor, that have worse vegetation, and we can add less minerals to the healthy part of the field, and also it can be used. It can be used for other purposes, not just for adding minerals. It also can be used for basically irrigation, where we can decide where we need more water to irrigate the field, and so on. It's basically some practical tasks that farmers do, and they need to know the variability of the field to convey these tasks. In this presentation, I will show you how these zones are calculated based on some semantic data from general publicly available data sources from basically Copernicus program. It's Sentinel-2 and Sentinel-1 imagery, and from this basically Sentinel imagery we can calculate from Sentinel-2 imagery we calculate enhanced vegetation index, and from Sentinel-1 imagery we calculate radar vegetation index. Then we see these indexes, and again we can estimate the vegetation health and yield potential based on it. As application we have created it, basically it is some prototype that basically the main thing is that we have created the services that can be then connected to any web application, and it
calculates this management zones within any field. In this example, we have created such application for Czech Republic, for basically Morava region, and here the farmer's idea is that the farmer opens it, then he selects his fields from land parcel identification system of Czech Republic, and then for example, he selects the most actual date of the index. Let's say that next week he needs to go to add some mineral to the soil, and then he generates these zones to create some application map and to add minerals. So two endpoints that we have created for this application is to get the dates of the product of this indices. It's basically one service called call it get dates, where you say which product you're interested in, either AV index or RVI index, and then you say for the location for which you need this index. And then the second service is this get zones, which basically calculates the zones for the field for the exact date, and it has some additional parameters, which is the number of quantiles. It means basically that the whole field is the values of the index on the field are divided into the number of quantiles that user needs. For example, 5 parts, and basically fifth quantile means that it's the highest values, the first quantile means the lowest values, and then also because the data can be detailed or contain some noise, so it's also the blur parameter that basically applies Gaussian smoothing filter to the data to basically to get rid of some noise. The processing basically is generally described here. Of course, it's a little bit more complex. There are some nuances. So the first step is to select imagery, or to select the product, the index for selected dates for the given location that user enters. Then we crop imagery by the field borders. User in this example of this application, user selects it from this land parcel identification system of Czech Republic, but in general it can be custom drawing of the borders by the user, or he can upload a file with his fields. Then we apply this smoothing filter to remove the noise, and user can set the standard deviation of this kernel of this Gaussian filter. Then we divide values into number of quantiles that user wants, and then we vectorize the zones to requested format and send to user. And basically this is the process for each field. So for example, if a user has 5 fields, we calculate quantiles independently for this field, because these are relative values. So additional services that involved into this application is the field borders from land parcel identification system. We have it as WFS service, and also to display the source data, we have created WMS WMS service that displays the source data of the index that we then display on the map. And now maybe I can go to the demo. actually it open somewhere. So this is how it looks. It's for now in Czech language. So here it's the interface. It's basically based on HS layers library that our company is developing, and then maybe I didn't say, but the files, the architecture, if we speak about general architecture, the files are stored in Linux server, and for computations we use Ogre and GDAL libraries. So here is, for example, I select some field and I have some basic information from LPs about this field. And then I select a number of quantiles that I want, for example, let's say 5 quantiles, and then the smoothing that I want to apply, and the number of products that I'm interested in. For example, I'm interested in AV index. Then I select the date. So, for example, let's say today, let's assume we have, because it's a test application, and we have older dates from last year, but let's say that today is 26th of April, so let's select something around 26th of April. So here it's 27th of April, for example, 2020, and I get the zones. So here is the result. Basically, the colors are selected in such way that the fifth quantile with the highest, like the most health vegetation is green, and the red is where you need probably the state of vegetation is poor, and more minerals need to be added to those areas. So and it's already like vector form, then user can download it and create application maps based on these zones. So for now, it's probably it's like now it's testing mode, but in the future, I think that we will keep these indexes up to date, and we will publish information about the addresses of these endpoints points, so that you can try to integrate those into your applications for farmers. So thank you for your attention, and maybe some questions if you have.
So I would like to ask is there some question to Dimitri? I don't see anything in the chat, so if there is some question online, you can ask him. Yes, there is the question about the clouds. Maybe that I can try to answer. Yes, we are now developing the line which will only select the images without cloud. Yes, in the current stage of this testing mode, we use all images, but of course we are now working on the selection, the field without cloud. But as already was mentioned in the first presentation from Herman, yes, some years are not very good because last year was very difficult. So there is also that we are now starting testing this Sentinel 1. Currently, again, I am answering of the question of Barea. We are testing now. We are dealing now with RVE. It is Sentinel 1 indexes, but generally, this zoning could be done from any type of indexing, and it's depend on the need and test, because such zoning will be able to do on any type of indexes. Of course, we will need to look on this possibility of the cloud-free images, but generally, due to the fact that the calculation is done separately for every field, the idea is that we will select not all images, but that we will select the best images for every field to be possible to calculate the zoning, yes, because the zoning is influence only with the data from this one concrete field, and for other field or for other farm there could be used other data. But here was main focus now on or is on the preparing of the algorithm, and as Dimitri mentioned, the idea is to offer API which will allow to call this functionality from other solution, other application, and on the end it will be show how this could be integrated already into the application. There will be now a short demonstration of Farm Insider application, which is one from the solution for preparing of
Farm Insight, not Farm Insider.
Farm Insight, sorry. And there will be a presentation of this application, and also showing how such type of zoning could be integrated into the applications. So, Junior, floor is yours.
Okay. Hello, I will start sharing screen now. Do you see the screen?
Yes.
I am Karel Charvá, Junior from Les Projekt Služby, and now I would like to show you the demonstration of application which is designed for farmers to be able to prepare variable rate application maps based on different zoning. The first version of the application was developed under the Data Bio project in Horizon 2020, but we are continuing with this development after the end of the Data Bio project, and it will be offered under the name Farm Insight. So what's the basic idea of the application? It offers the farmer or agronomist the possibility to manage his fields and to display and use the relevant data for the fields and generate variable rate applications map, either by manually drawing or by using some of the products which are or will be integrated in the application. So now I will create new test project. And in Czech Republic and Slovakia, we are directly connected to the LPIS, to the public part of the LPIS database. So if I know the name of the farm and the location, I can directly import the fields of the farm. The interface is in Czech, so I will explain everything. Now I am entering the region, then the cadastral area, and now I will select some farm in the cadastral area. The farm is located in more cadastral area, so this will be only from this one cadastral area. And I select only arable land and create the project. So now I have automatically imported the fields of this farm in the selected cadastral area. And now we can do various things with the fields. So there is possibility to manually add more fields if I display the LPS layer and I would want to add any other field. I just can simply select the field and import it to the project. Or if there won't be available the LPS data in the system, for example, it will be in some other country, there is also possible to import of shapefile and combine it with this project. So now let's say I will work with this field, and now we can see a yield potential map. It is a rough map without corrections of fields where the field was divided, and this is computed for the whole Czech Republic. For some more precise calculations, it will be necessary to manually check and do some manual computations of this yield potential by our advisor. But as you see, and as already some colleagues before showed, if the field was separated to more crops and it is not recorded in the system, then we can see some very significant stripes or significant borders between the different colors. And on some other fields, it is more natural, and it is where the field wasn't divided. This yield potential is computed based on 6 to 8 years series of EVI vegetation indices, and the different colors show the relative distribution of the yield within the field. So it is not for comparison one field to each other, but to comparison of relative long-term estimated variability of the yields. So let's say that farmer would like to import more fields, and for example draw application map based on this yield potential. Now I will do very rough sketch. So I will create the map of zones and select that we would like to have 3 zones with low, average, and high yield. And now I will switch to editation and roughly sketch the zones. So I will select some polygon for editing of the zones, and it will be only a rough sketch, but the farmer would be able, or the agronomist would be able to go like this and sketch the zones within the field. It's only very quick, rough sketch by hand. Then I will assign the high, low, or average value to the zones. The default is average. So let's say here I will assign the high value and low value to the middle. I will save it. And save the map of the zones. And now, if I would assign some doses for variable rate of application, for example, nitrogen, attribute N, kilograms per hectare and the amount. I will be able now to download the map as shapefile to use it in to import it to the agricultural machinery for variable rate application. And this is one of the possibilities, but now I will switch to different project. And here is the yield potential calculated on demand with some manual correction for selected fields on one farm. So this kind of yield potential, if we again define the doses for the variable rate application maps, can be directly imported as application map and downloaded for use in the agricultural machinery. But now I will switch back to the previous project. And beside this yield potential, based on the long-term variability of the vegetation indices, we are also starting to integrate the tools and algorithms that Dimitri was showing before. So it would be other possibility how to prepare some data for the application maps. So the tool is here called Field Calculator, and it is using the automatic zoning for the selected fields. So now I will select some scenes for the EVI index. And yeah, I haven't switched on the layer. And now the zoning is automatically computed and generated on fly based on the available remote sensing data. I can try to do it for any other field. So at this point, we have the EVI index here, but in future, we would like to involve more possibilities and somehow adjust the smoothing of the zones because it is not optimal yet. So unlike the previous, which was on long-term variability, this is the zoning of the field based on one scene, and it again can be downloaded as variable rate application map. This application also involves possibilities for merging and splitting the fields and various kind of editing, but I don't think we have time for showing these possibilities now. So it's all from my side now. Thank you for your attention. If there are any questions, I can try to answer.
Okay, thank you. Are there any questions to this presentation? If not, yes, you saw that now we are working on all chain, how to use satellite data till final recommendation that there is necessary to solve number of things, including of selection of images and other. Of course, the idea is that we would like to offer cooperation to other and to use this type of the services also for other application. We are now also testing the possibility of Sentinel-1 because, as Herman mentioned, some years we can have problem with Sentinel 2 data. So we will be very happy on any research and also commercial cooperation. So if you would be interested, please contact us. As I mentioned on the beginning, this is the part of the series of the webinar organizing as part of INSPIRE Hackathon. And if you will, Shark, or anybody, if you can share the link to the hackathon, you can see here the challenges which are related to this, and you can register and speak with our colleague how will be possible to cooperate, how will be possible to extend it, these services. So please join our effort. This virtual hackathon will run till end of May, so there is the time to select the topic which is most interesting for you and to start cooperate with our team and with the people on the development. It is not our last webinar. We had already one webinar a week ago when we spoke about App for Everybody. This webinar is already recorded and you can see the video which is on YouTube. I hope that tonight we will have also a video from today. So if you will need to check some things more detailedly, you can go for the video. And as I can recommend it, please join our teams and start cooperate. There will be possible to discuss with our colleague this different topic what was presented. Now I would like to make also some announcement. We will publish tomorrow. Next Tuesday we will continue with the webinars which will be focused on utilization of IoT technologies. So anybody who will be interested about IoT, join us next Tuesday. You will again receive information about this webinar, and next Friday we will continue with the webinar about open land use map. It will be focused on building open land use map in Europe, Africa, but we will also show our experiences from the China, which we done also. So next week will be 2 webinars. Tuesday will be IoT, Friday will be this open land use. You will receive information. Please follow also the web pages of Plan for All, where all this information will be. And also tonight you will, or tomorrow morning, you will receive information about with the link to the video. So if there is some other question, please you can ask now. I don't see there any other question. I don't see any question. Then is here. So please, I would like to thank to all presenter. I would like to thank to all people, and we will meet again next Tuesday. So see you. Goodbye.
Bye. See you.
Thank you.
Goodbye.
Thank you.
Thank you. Goodbye.
Ciao, ciao, guys.